And now we come back to that summation. So if we insert them now, W2 is now going to be, whereas if I insert the double excited determinants, all double excited determinants, and I can do that either, so I have to have now, instead of the sum over all determinants, I want to use now those indices to distinguish between the determinants. So I have all double excitations. And I should again have all unique double excitations. So I have a pair of, so either I and j, sum over I and j should not be the same. Well, they should not be the same, and I also have the unique pairs. So the same over A and B. I also could let them run free, and then I have 1/4 instead of. But that's a minor detail. So this is over occupied orbitals, that's over virtual orbitals. And then I get my SCF, the perturbation Hamiltonian, and I get IJAB. IJAB. H prime, my SCF. And what do I get in the down here? I get H0, so that's the sum over the orbital energies of SCF, minus the sum over the orbital energies of a Slater determinant where I and j was replaced by A and B. Now this is the sum over epsilon I all occupied, but minus, now before I made the double replacement, that was also a sum over all, well, let's call that K for a second. K. That was originally also a sum over all occupied orbitals, but now I removed I and j. So it's that sum minus epsilon I minus epsilon j, because those were not included in the set. Instead of, I have epsilon A and epsilon B. So that gives me at the end epsilon I plus epsilon j minus epsilon A minus epsilon B. It just gives the difference between those orbital energies which are different, those orbitals, the energies of those orbitals which are different in those two determinants and those in those two energies. So that's the denominator. That's simple, it's just orbital energy differences. Now, what do I get up there? Well, first of all, this is the same matrix element twice. Slater determinants, we have real orbitals, so these are real determinants. So this is just a complex conjugate of this, but since all functions are real, the complex conjugate is just the same number. So I could equally write just this squared. Well, what kind of matrix element is that? Now I still have my 2 electron and my 1 electron operator. The difference is in 2 orbitals, 2 Slater determinants different in 2 orbitals and a 1 electron operator, that is just 0. Slater-Coulomb rules. So I actually only have this. So we have the case of, so I still have my sum over I larger than j occupied and A larger than B occupied. I have in the denominator epsilon I, epsilon j, minus epsilon A, minus epsilon B. And up there I have something squared, because those two are the same. And so the question is, what do I get with the 2 electron operator Slater-Cohen rules if I have STF and a double excited determinant. Well, that gives me the two electron integrals with exactly those orbitals in which they differ. But because this is a Slater determinant, not just a product function, I get a Coulomb integral minus the exchange version. So I get IJAB minus IJBA. I get it twice, I get it squared. This is the second order energy correction.